Hello friends, in this video, in this session, we are going to see all the remaining topics related to our chapter, that is modules. Okay, so we will start now. We will see how to compile and run the module-based service example. In the previous session, we have seen the example and the steps to follow. And once you have performed all the steps that are given in the preceding session, you can compile and run the example by using the command javac -d app modules -- module source path app source user function implementation module info.java app source app start mymod app demo mymod app demo.java. Okay, so you have to note down or understand this command. Then java -- module path app modules -m is for module app start / app start dot mymod app demo dot mymod app demo. Okay, so these two commands are for javac is for compiling the example in the previous session, and your java is for the running the example. Okay, this was our example. The example was binary function provider. First was your absolute plus and absolute minus. Okay, this was our example that was iterating through the for loop binary function provider BFP LTR. Okay, so using service loader, we were creating the object, and using the load command, we are also providing the class. Okay, so instead of modifying the main project that we have created in the first session, we only modified the runtime type information about that project. Okay, so we will load this class binary function provider as externally. Okay, so this was the mymod app demo. This is the main function. Okay, and in this main function we have modified all these things for absolute plus and absolute minus. And what was the effect of absolute plus and minus? Absolute was addition of two absolute values a and b, absolute of a plus absolute of b, and this get was giving us the object of absolute plus as well as absolute minus. Okay, so we explain this, and to run this project, these are the two commands we are going to use. Javac -d app modules module source path app source module info.java mymod app demo.java. Okay, and then java -- module path app modules -m app start mymod app demo.mymod app demo. So output is 2 is the factor of 10, smallest factor common to 35 and 105 5, largest factor is 7. Result of absolute plus function that we have provided by the binary function provider externally as a plugin, output it out of it as 16 and 8. Okay, binary functions were located and executed using that command. It is important to emphasize that if either the provide statement in the user function implementation module or the usage statement in the abstract module were missing, the application would fail. Okay, so if one module is providing the service, it should be including in the definition of module as a provide keyword, and abstract is using the service, so abstract should use the usage statement or usage keyword. Okay, so it is necessary, or you can say it is compulsory. If you will use those both keywords as provides and abstract, then only your project will run. Otherwise, your project or application would fail. Okay, the preceding example was kept very simple for the sake of understanding. That was very simple example to clearly illustrate module support for services. So how services are used by modules as external plugin, but much more sophisticated uses are still possible, or much more complicated projects we can still create. You might use the service up to provide a sort method that sorts a file. Okay, this is just an example. If you want to sort the file, you can externally give a service to sort. Okay, so service provider will give the implementation of sort, and your class or your project will use that sort method, that sorter file. Various sorting algorithm could be supported and made available to the service. Okay, so sorting algorithms are dependent. Okay, bubble sort, quick sort, like this. The specific sort will be chosen based on the desired runtime characteristic, nature and size of the data, where the random access of the data is supported. Depending upon that, your service provider, you can build it, and any service provider can still use the same service. Okay, you might want to try implementing such a service as a way to further experiment with services in service. Okay, so if you want to use that sort method, you can try implementing at home, such a service at home, as a way to further experiment with services in models. Okay, so just for the sake of understanding or a practice. Okay, when you will practice, you will understand it better. Then module graphs. A term you are likely to encounter when working with modules is the module graph. Okay, when you are working with modules, specifically, you will have the term like module graph. During compilation, the compiler resolves the dependence relationship between modules by creating a module graph that represents the dependency, like which module is dependent upon which module. Okay, so that will be represented in the graphical representation. The process ensures that all dependencies are resolved by using that module graph, including those that occur indirectly. Okay, so directly dependence or indirectly dependence, both are included in that particular module graph. That will tell you the relationship between modules, which module is dependent upon which module. If module A requires module B and B requires module C, then there is a then the module graph will contain module C even if A does not use it directly. So that you will understand that A is also dependent upon module C. Module graphs, like a transitive dependency we have seen. Module graphs can be depicted visually in a drawing, like a graph representation, a graphical representation to illustrate the relationship between modules. Okay, so for example, there are 6 modules A, B, C, D, E, F. A requires B and C, B requires D and E, and C requires F. So this is just an example. The following diagram we are going to see now, that will depict this relationship, so that you will understand which module is dependent on which module. Because java.base is automatically included, it is not shown in the diagram. It is like a java.lang. This package is automatically included. That's way your java.base is automatically included. Okay, so this is the diagram. Okay, A, B, C, and E, F. A, B, C, D, E, F. So A is dependent upon B, C, B is dependent upon D, E, and C is dependent upon F. Okay, A requires B and C, B requires D and E, C requires F module. Okay, the arrows point from dependent module to the required module. A drawing of module graph depicts that which module have access to which other modules. Okay, only the smallest applications can have their module visually represented, because the complexity typically involved in many commercial applications. Okay, so commercial applications, or the application that generate revenue, real world application, have many complex module structure. So in that case, we cannot represent it in a graph typically, because of this, typically very small applications or very small things can be generalized or structured in the graphical representation like this. Okay, this is a very simple graphical representation. For the more complex programs, it is not possible, because the complexity increases in the complex projects. 3 specialized module features. Now, in the previous example that we have already seen, key features, we have described the key features of modules supported by Java language. and they are the features on which you will typically rely when creating your own module. So some features we have already introduced or described. There are three additional features still there, additional module related features that can be quite useful in certain circumstances. Okay, so instead of the features that we have seen till now, there are three additional module related features. These are the open modules, the open statement, and the use of requires chatting. Okay. Each of these features is designed to handle a specialized situation, and each constitutes a fairly advanced aspect of the module system. Okay. So we will see each one by one. It is important for all Java programmers to have a general understanding of their purpose. First is open modules. The types in a modules package are accessible only if they are explicitly exported via an export statement. Okay. If it is not exported via an exports keyword, even if it is a public package or public thing, it will not be given or accessible to another module. While this is usually what you will want. Okay. But there can be circumstances in which it is useful to enable runtime access to all packages to or in the module, whether the package is exported or not. Okay, so you have to keep that module open at runtime, even the package is exported or not. So when you are creating the open module, all the packages inside by default they become public and they become accessible to another modules. You can create a open module for this situation. Open module, module name, module definition. Okay. So at runtime, it will be accessible to all the modules. And it is declared by preceding the module keyword with the open modifier. In an open module, types in all its packages are accessible at runtime. Okay. Types in all its packages are accessible. All types are accessible at runtime. That is, it is open to all. That only those packages are explicitly exported at available at compile time. Okay, but at runtime they are open to all. The open modifier affects only runtime accessibility. Okay, if you want to have your module accessible to another module at compile time, you have to explicitly give the exports keyword. Otherwise, your package or your types in that module will not be accessible to another module. But if it is open, it will be open at runtime to all modules. The primary reason for an open module is to enable the packages in the module to be accessed through reflection. Okay, how they are accessed? Through reflection. Reflection is a feature that lets the program analyze code at runtime. Okay, what is reflection? It lets the program analyze code at runtime. Next is open statement. It is possible for a module to open a specific package for runtime access by other modules and for reflective access rather than opening an entire module. Okay, rather than opening entire means completely opening. Rather than completely opening, what you have to do, it is possible for a particular module to open a specific package for runtime access. When it is open module, it is accessible to all modules completely. But if it is an open statement, it is possible, if it is using the open keyword, it is possible for that module to runtime, give the runtime accessibility to particular package at runtime and for reflective access rather than opening an entire module. So that for that purpose, we are using the open statement or open keyword, opens package name. So that opens package name is the package name which will be available to another modules at runtime. Here package name specifies the package to open. It is also possible to include a to clause open to particular module, which means name, which names those modules for which the package is open. Okay, so you can combine the opens keyword with a to clause. It is important to understand opens does not grant compile time access like a open statement. It is used open like a open module. It is used only to open package for runtime and reflective access, only at runtime and reflective access. Okay, but you can both export and open a module. Okay, so it is possible to combine the exports keyword and open module, open a specific module to specific particular module. Okay, open statement cannot be used in an open module because by default open module opens all the packages in that module to all the modules available at runtime. Okay, so one modules all packages are open to all, but you cannot combine open module plus open keyword. It is not allowed. All packages in an open modules are already open, so there is no use of using the open keyword at in the open module. Then next is require static. Third thing is require static. Require specifies the dependence that by default is enforced both during compilation and runtime. Okay. So what is the use of requires? One module is requiring another module. It specifies the dependence. By default, it is enforced both during compile and runtime. It is possible to relax this requirement in such a way that module is not required at runtime. Okay, so it is only required at compile time. This is accomplished by use of static modifier in require statement. Okay, so when you are giving a request, one module is requiring another module only at compile time, not at runtime. Okay, so when you are combining static requests, so it is only requiring at compile time. So module A static requires B means only it is A only requires the B at compile time, not at runtime. This specifies that my module is required for compilation, but not at runtime. Requires static my module. The addition of static makes the my mod optional at runtime. So this criteria is relaxed at runtime. This can be helpful in situation like a program can utilize functionality if it is present but not required. Okay, like a program can utilize a particular functionality, only it can utilize but not required, not actually necessary. Introducing JLink and module jar files. Okay, as the preceding discussions have shown, modules represent a substantial enhancement to the Java language. So it has enhanced the Java language in better way. The module system also support enhancement at runtime also. One of the most important is the ability to create runtime image that is specifically tailored to your application. Okay, so what is important thing is ability to create a runtime image that is specifically tailored to your application. So it will create a runtime image particular for your application as and when required. Okay, so like we have seen open module, require static. That will differentiate the requirement at runtime as well as compile time. So you will create the image as it is required, that is specifically tailored for your application. You can use JDK tool called JLink. Okay, it combines a group of modules into an optimized runtime image. So you can use this tool JLink that will combine a group of modules into an optimized runtime image depending upon your need and your application. You can use JLink to link modular jar files, JMod files, or even modules in their unarchived exploded directory format. Okay, so what is the uses of JLink? It is used to link modular jar files, JMod files, or even modules in their unarchived exploded directory format. Linking files in an exploded directory. Let's look first at using JLink to create a runtime image from unarchived modules. Okay. So first of all, we will see what is JLink. To create a runtime image from unarchived modules. How to create a runtime image from JLink. The files are contained in their raw format in fully expanded, that is exploded directory. When you are archiving your files, like if you have any image, PNG image, you are archiving, it will be compressed and its size will be shrink. Okay, and when you are unarchiving or exploded thing, PNG will come out in its original format. Okay, so it will be called as a exploded format. Okay, so raw format will have their actual size and actual format, and archive format will have their shrink or compressed file. Okay, assuming a Windows environment, the following command links the modules. For the first example that we have seen at the start of this chapter, links the modules. It must be executed from a directory above MyMod application. JLink launcher MyMod app is equal to abstract.mymod.app.demo, MyMod.app.demo, module path Java home, JMods, MyMod app modules, add modules, abstract output mylink mod app. Okay, so this command should be executed, must be executed from a directory directly above the MyMod application directory. So now we will explore this command. Launcher option tells the JLink to create a command that starts the application. Okay. Launcher tells the JLink to create a command that starts the application. It specifies the name of the application and the path to the main class. So this launcher will create a command that will start your project, launch your project, and then it specifies the name of the application and the path to the main class. The main class is MyMod app demo. Okay, launch this MyMod app demo. Okay, from abstract.mymod.app.demo, MyMod app demo. Okay, this is the main class. Name of the application and the path. The module path specifies the path to the required modules. This module path will give you the path to the required module. What are the required modules? The first is the path to platform modules. The second is the path to the application modules. The required path is, first is the platform modules like JMods, MyMod app modules, and second is the application modules. Add modules, abstract output. First is the path Java home, and second is Java home JMods, and second is the application mod, MyMod app modules. Use of environmental variable Java home. It represents the path to the standard Java development kit directory. In a standard Windows installation, the path will typically be something like C program file Java JDK 17 JMod. But use of Java home is both shorter and able to work no matter in what directory JDK was installed. Okay, so you don't have to go to your external variables and then copy the path. You can directly use the name Java underscore. Add modules option specifies the module or modules to add extra modules. Okay, add modules, abstract output mylink app mod app. Okay, so abstract is the module to be added and output is mylink mod app. Only abstract is specified. This is because JLink automatically resolves all dependencies and removes all required modules. And output specifies the output directory, and which is given is mylink mod app. Okay. After you run the command, a directory called mylink app will have been created as output directory that contains the runtime image. Okay. So this way we can create the runtime image of our application. In its bin directory, you will find a launcher file called MyMod app that you can run the application. Okay. So MyMod app, you have to double click, and after double clicking, you will have the runtime image of the application. In Windows, we have batch file that is the program. Now we will see linked to modular Java file. Although link to modules from their exploded directory. Exploded means complete directory convenient when working on real world code. You will be often using jar files. Jar stand for Java RG. The file format typically used for application deployment. Okay. For the real world application, you will not see or you have files in an exploded form. You will have the jar files or a RG form. RG form is jar Java RG, and its file format is used for application deployment. In the case of modular code, you will be using modular jar files. Okay, dependent upon that. Normal jar file and modular jar file. Modular jar file is one that contains modules info.class file. Okay, so it is included module info.class. A jar tool that has the ability from Java 9 to create modular jar files. From Java 9, the jar tool has the ability to create modular jar file that is having module info.class. Okay, it can now recognize the module path automatically. Once you have created modular jar files, you can use JLink to link them to runtime image. Okay, so directly, when you have created the modular jar file, you can directly use JLink to link them to a runtime image. Now we will see the example. Again, assuming the first example, here are the jar commands that create a modular jar file for the MyMod app demo program. And it must be executed from directory directly above MyMod app. Also, you will need to create a directory called applib under MyMod app. Okay, so under MyMod app, you have to create this folder applib jar create file is equal to MyMod app applib app functions.jar dash c MyMod app app functions. Okay, so here are the jar commands. We are going to see that create modular jar files for the MyMod app demo program. Jar create file MyMod app demo, MyMod app applib appstart.jar. Main class is MyMod app demo that is having public static void main dash c MyMod app app modules appstart. Create tells the jar create new jar file. File option specifies the name of the jar file. Okay, name of the jar file is MyMod app applib that you have created as a folder. Here it will create app functions.jar. Then files to include are specified by dash c. So these files are to be included MyMod app modules app functions. Okay. The class that contains main is given by main class option. Okay. Then again file create appstart.jar app functions.jar is already created. Now it will create appstart.jar. Main class is MyMod app demo and files to include are specified by MyMod app modules appstart. Okay. After running this all commands, the jar files for the application will be in the applib directory under MyMod app. So jar files will be created after this command, and those will be included in applib directory under MyMod application that you have created. Given the modular jar files that we have just created, these are the commands that links them. JLink launcher MyMod app is equal to appstart. Module path Java home JMod and MyMod app lib. Then add modules to be added appstart, and output link is mylink mod app. The module path to the jar file is specified, not the path to the exploded directory. Otherwise, the JLink command is same as before. Okay. Only the module path to the jar file is added. Okay. JLink launcher MyMod app appstart, and here applib MyMod app lib. Okay, that app lib we have created, and all else is same. As point of interest, you can use the following command to run the application directly from the jar files. Java-p MyMod app applib -m appstart. So Using this command, you can directly run the application from the jar files. Here, your jar files will be located in applet directory. Okay, and it must be executed from a directly above the my_mod app. -p specifies the module path, and -n specifies the module that contains the program's entry point. Okay, this is the module path, my_mod app this, and this is the entry point. Okay, next is jmod files. The JLink tool can also link the files that use the newer JMod format introduced by Java 9. Okay, so JLink tool that you have already seen in this session can also link files that use the newer JMod format. That can also link the files that use the newer format, JMod format introduced by Java 9. JMod files can include things that are not applicable to jar files. Okay, new things are also included. They are created by new JMod tool. Although most applications will still use modular jar files, JMod files will be of value in specialization. Okay, so for the sake of understanding, we are introducing here JMod files. Beginning with Java 9, the platform modules are contained in Java JMod files. JLink can also be used by simply added JPackage tool. Okay, so how to use the JLink? By the simply added JPackage tool. This tool can create a natively installable application. Brief word about layers and automatic modules. So when you are learning about modules, we will have two additional features, layers and automatic modules. Both are designed for specialized advanced work with modules, layers and automatic modules, or when migrating existing applications. So new things are layers and automatic modules. Although it is likely that most programmers will not need to make use of this feature, a brief description is given in the sake of for the sake of completeness. Okay, most programmers do not use these layers and automatic modules, but for the sake of in the interest of completeness, we are giving it here. The module layer associates the module in a module graph with the class loader. Okay, module layer will associate the module in the module graph, the class loader. Different layers can use different class loaders. So it will give you a layer. Every layer will have different class loaders. So that particular module layer associate the module in a module graph with the class loader. So class module will be attached with the class loader. It's already designed graph. So different layers in the graph can use different class loaders. Layers enable certain specialized type of applications to be more easily constructed. Certain specialized means certain real-world applications more easily constructed. An automatic module is created by specifying a non-modular jar file on the module path. Okay. So what is automatic module? It is created by specifying a non-modular jar file on the module path, which is its name being automatically derived. Whatever the module path is there, whatever the already existing module path is there, automatic module is created by specifying non-modular jar file in that particular module path, with its name being automatically derived. It is possible to explicitly specify a name for an automatic module in the manifest file. So you can explicitly specify name if you want. Its name will automatically derive, but you can also explicitly specify name for an automatic module in the manifest file. Automatic modules enable normal modules to have a dependence on code in the automatic module. Okay, what is the use of automatic module? It will enable normal modules to have a dependence on code. Normal module will have dependence on code in the automatic module. So both will be connected using automatic modules. Automatic modules are provided as an aid migration from pre-modular code to fully modular code. So it will be used as a connection between pre-modular code, normal modular code to fully modular code. They are primarily a transitional features. Automatic modules are transitional features. So finally, what are modules? We are having the final touch or final thoughts on modules. Preceding discussions have introduced and demonstrated the core elements of the module system. And these are the features about which every Java programmer should have at least basic understanding. Okay, so all the topics we have covered so that we will have at least basic understanding related to modules. As you might guess, the module system provides additional features that give you fine-grained control over the creation and use module. Okay, so module is already introduced and additional features are also given so that you can use the module effectively. For example, both Java C and Java have many more options related to modules than described in this chapter. So whatever you have understood is for the sake of basic things. Because modules are significant addition to Java, it is likely that the module system will evolve over time. Many more additions will come to modules. You will want to watch for the enhancement to this innovative aspect of Java. Okay, as and when you will understand about the modules and be interested in learning about modules in the future, you will want to watch for enhancement to this innovative aspect of Java. Okay, so this way we have completed the modules theory part. In the next session, we will try to cover all the chapter or all the practical part so that you will understand how practically we are implementing modules. Okay, so meet you in the next session, the practical part. Thank you so much.